Hello students, and welcome to Chemistry B. I'm Miss Slate, and today we're going to talk about how to balance chemical equations.
In this next displacement, we are pouring colorless silver nitrate solution into a beaker containing a copper coil. We notice that as the silver nitrate solution touches the copper, the coil immediately darkens and thickens. Copper is reducing silver ions to silver. When we take a closer look, we can see the silver crystals on the surface of the copper. Now, after some time, we also notice that the solution has turned blue because copper ions are formed. Copper has been oxidized to blue Cu2+. As we shake the wire, we see the large amount of silver that has been displaced.
Okay, so silver nitrate reacting with copper metal produces copper 2 nitrate and silver metal. So we saw that was a clear chemical change. We had a new solid forming. We had a color change in the solution. So how do we represent that as a balanced chemical equation? Well, first off, on the left, we always write what we call our reactants, which are the substances that we start with. And then on the right, we write the products, which are simply the substances that we end with. So in this case, we are starting with our reactants of silver nitrate and copper, and we're ending with our products, copper 2 nitrate and silver. So to go to the next part of a chemical equation, we represent these compounds and elements symbolically. So as a reminder, like I said, reactants are the compounds that you start with in a chemical reaction. They're always on the left side of the equation. Products are the compounds that you end with in a chemical reaction, and they're found on the right side of the equation. Subscripts, remember from when we were writing formulas, subscripts, they represent the number of each element or ion in a chemical formula, and those are the little numbers in the chemical formula. Chemical equations also involve coefficients. Coefficients represent how many molecules of each compound are in the balanced equation, and they are the big numbers that we write in front of the formulas. So some various symbols that we use in chemical equations, plus that separates different reactants from each other or different products from each other. The arrow separates the reactants from the products. And then we use these little subscripted letters to identify the state of matter each reactant or product is in. So S stands for solid, L stands for liquid, G stands for gas, and then AQ stands for aqueous. So that is where you have something dissolved in water or a water solution. So there's a couple of different ways that we can go about balancing equations. But first, it's important to talk about why we balance equations. We balance equations so that there is the same number of atoms on both sides of the chemical equation, because that's how we show that mass is conserved in a chemical reaction. So if you remember back to Chemistry A, in Chapter 3, we talked about how the mass of a system doesn't change whether it undergoes a chemical or a physical change, as long as nothing gets in or out of the system. So to represent that phenomenon that mass is conserved even during a chemical change, we always need to have the same number of atoms of each element on both sides of our chemical equation. So that is the purpose of balancing chemical equations. It's how we show that we are in line with conservation of mass. So there's two main methods for balancing equations, and we're going to go over examples of each of them. First off is the counting method. In the counting method, we just add molecules to each side of the reaction and go back and forth until the number of elements is the same in the reactants and products. So our example is the separation of water. So that's where H2O liquid decomposes into hydrogen gas and oxygen gas. Okay, so I start with, I've got 2 hydrogen in the reactants and 2 in the products, so that matches up. I have 1 oxygen in the reactants, I have 2 in the products. Well, the only way for me to get more oxygen in the reactants is to add another water molecule. Now, I can't just add an oxygen atom to this side, I have to add the entire molecule, because you can't add things that aren't already in the equation. Okay, so I can't just add an O, because I don't have just an O, I just have H2O. So now I've got 1, 2 oxygen in the reactants, 2 in the products. So I go back and I double check hydrogen. I've got 2, 4 in the reactants. I have 2 in the products. So I need to add another hydrogen molecule. Now I've got 2, 4 hydrogen, 2, 4 hydrogen, 1, 2 oxygen, and 2 oxygen. So this is a balanced chemical equation. And so all that I have to do is use coefficients to represent the number of molecules. I've got 2 water molecules, so I put a coefficient of 2. I've got 2 hydrogen molecules, coefficient of 2. And then I have just 1 oxygen molecule, so I don't necessarily need a coefficient of 1, but like on the worksheets, for example, if you're someone who really doesn't like having an open blank, you can put in a coefficient of 1. But typically, if the coefficient is 1, you just don't write it. The counting method is nice because it's really simple, but it can take quite a bit of time to get the answer for more complex reactions. So let's look at another main method. This is called the factor method. So you're going to create a T-table listing the number of atoms for each element in the reactants and the products. And then we're going to multiply by factors to make the number of atoms for each element equal. And the factors become our coefficients. So our example here is creating ammonia. So ammonia is created when hydrogen gas reacts with nitrogen gas, and it produces ammonia gas. Ammonia being NH3. So I'm going to make a T-table off to the side. So here's my T-table. The left side is for reactants, the right side is for products, and then I'm going to list my elements along the outside. So I've got hydrogen and nitrogen atoms. And I'm going to start by listing how many I have on each side. In the reactants, I've got 2 hydrogen, 2 nitrogen. In the products, I have 3 hydrogen and 1 nitrogen. Anytime you're using the factor method, I highly recommend that you balance everything that's not hydrogen and oxygen first. Always leave hydrogen and oxygen for last. It just makes it a little bit easier in your process a lot of times. So in this case, I only have 1 nitrogen in the products, but I've got 2 in the reactants. If I multiply by 2 in the products, that will give me 2 nitrogen. Multiplying by 2 in the products means a coefficient of 2. What you multiply by is the coefficient. This also changes my number of hydrogen in the products, though, from 3 to 6. Because 2 times 3 is 6. So now I have 2 hydrogen in the reactants, 6 in the products. So if I multiply by 3, 3 becomes the coefficient. I'll get 6 hydrogen in the reactants. Now it looks like all of my atoms add up. I've got 6 and 6 hydrogen, 2 and 2 nitrogen. So this is the balanced chemical equation. Again, nitrogen gas here has a coefficient of 1, but you don't have to write it. There are other ways to balance chemical equations. These are just a couple of the methods. It doesn't matter what method you use. I just always say pick one that makes the most sense to you.